Welcome back to Overhaul Overland. The fuel injection pump, the injectors are going to our diesel specialists, Dup Diesel. So Dup Diesel is a family-owned business. They've been in the industry for many years, and they're part of a nationwide network of Bosch Diesel fuel injection specialists. It's very important to check out the fuel injection system, because over time, as you use your engine and as the mileage creeps up, the fuel that goes through the injectors in the pump can degrade and wear those components by having your injectors overfuel the engine, spraying more fuel than is needed into the engine, taking away the oil from the pistons and causing premature wear. That's critical. So we're here at Dup Diesel and I've brought in 3 components from the vehicle. We've got the injectors, we've got the injector pump, and we've got the turbo. Now I really wanted just to ask you, Dirk, what do you see and look at first off? Now we've got the injector here. What are you looking at besides the injector to tell us there's a problem before you strip it?
Okay, thanks Paul. Looking at it as a visual inspection, we can see that it's components that came off an engine that was running for quite a long period or excessive service life.
Yeah, 450,000 kilometers that this motor's done.
That's how much it's done. That's a lot.
So it's a lot.
So we will be definitely seeing a lot of wear inside these components that you brought in. On the injectors, the wearing parts is the front section, the nozzle as we call it.
Hey, this is the top bit up, yeah?
No, yeah, the front that goes into the cylinder head, sprays into the combustion chamber. This piece here sits in the flame of the combustion chamber. So it was sitting and looking at these 4 injectors on face value, we can see that if you look at that area there, never was there a spanner or a tool that touched it. Yeah. So these, we can accept that this 4 injectors is still original as it came out the vehicle, as it came out of the factory when the vehicle was manufactured.
Well, that's quite valuable when you see that, because often injectors can be rebuilt and badly.
Well, that's our work. We do refurbishment of the injectors, the turbocharger and the fuel injection pump. So as we would say, these are virgin injectors, they haven't been touched before. And the same with the pump. I just had a look quickly. Normally when the guys remanufacture or repair the fuel injection components, you would see that they use a different color paint to seal it, or they'll stamp a job number onto it or something like that. But I can't see any job numbers here or paint or anything from a previous workshop or that it's been done before. So we've got good components for this exercise that we're doing, looking at where and what can go wrong into these components. So the 4 injectors, the pump and the turbo. As I say, visual inspection shows that the nozzle, the seating area or the front section of the nozzle is already burned away. The nice part is every injector has got a unique part number and the nozzle's got a unique part number as well. So this nozzle will go with this body and it will go and we'll have a specific opening pressure for it. So there's nothing we can change in terms of spray pattern and stuff like that. So if we do the cross-reference and we find the correct nozzle for the correct body and we set it up to the correct pressure, we know it'll be okay for the engine that you guys are rebuilding. Same with the pump. It's got a specification that will be set to, but we'll deal with that when we get later. And there's also the turbocharger. There's some settings that must be checked once we get to the assembly part of it. So as you were asking, what do we see here? We see it's worn components. The injector is worn on the front. What happens there? The spray hole gets bigger as that section there sits in the heat. The material actually burns away slightly. It goes concave, which makes the spray hole wider. So that what you might find on older vehicles, once you accelerate, you see the black smoke comes out. That's because of the spray holes that's getting too big, that you're getting too much fuel. And that's what they would say, no, it's overfueling. Yes, it's not. It is overfueling, but it's not because of the fuel pump is causing it to overfuel. It's because of the wear that's in the injector or on the injector, causing the fuel to not atomize correctly and not be sprayed into the combustion chamber correctly. The correct service interval, this is what we call a pintle injector. It's got a flat top there. You get a long stem injector, which will be in like a direct injection engine that goes straight into the combustion chamber of the piston. This is a pintle injector. It sprays into a combustion chamber, which then goes onto a flat top piston into the head, like the engine you guys are rebuilding.
Yeah.
It's a KZTE type
That's
of
right,
engine,
yeah.
older Prado.
Yes.
So yeah, yes. So we're gonna replace this and set it up, and
then on the pump, which is like the heart, that people don't always, they sort of get this call that you've got a big expense on the go, and you know, things haven't been maintained. We know the mileage is against us, yeah.
yes.
But what should people have done along the way? I mean, what's important?
What I wanted to say on a pintle injector, normal service procedure on them is around 120,000 kilometers. So that set of injectors should have been reconditioned about 3 times in the life of that vehicle.
Of the vehicle, wow.
From 0 to 100 to 120,000 kilometers, we would have said yes, new set of nozzles, and then again on 240 and maybe then on 360 or whatever. The fuel injection pump, interesting component, it's get driven by the engine.
Yeah.
It's got electronics here that get the signals from the ECU from the engine, and then it's got a low pressure and a high pressure side here. The low pressure side sucks the diesel from the tank, through the filters, through a supply pump that's in here. We call it a vein pump.
Okay.
That goes through here, and it makes from the low pressure, goes into that section where there's a plunger and a reciprocating action that happens inside the pump. There's a plunger, and it goes through this, what we call a hydraulic distributor head assembly, and then distributes like a distributor of a petrol engine, a petrol car.
Yeah.
It distributes it to the cylinders, each to its different.
So instead of the spark
space.
plug leads, you've got the injector pipe going to each cylinder.
Yes.
Okay. From what you're seeing, we know we've got high mileage. We know we've got a pump that hasn't been worked on. So what are you expecting to find inside here when you open it up?
What we're going to see is we're going to see the drive shaft bushes probably worn inside here, because there's 2 bushes keeping the shaft. You see, when I do this, it can go inside there.
Okay.
We'll see worn drive shaft bushes. We'll see a worn supply pump. We'll see roller pins and bushes that's worn. We'll see a thrust washer that's worn. We'll see a plunger washer that's worn. All the gaskets and seals will be hard and brittle. If you look at that, there's a timing piston inside that moves forward and backwards. So it's all moving components, moving all the time inside this pump. And the pump gets lubricated from the diesel that's in the tank. So if you got incorrect diesel or contaminated diesel, that'll definitely cause this pump to fail much quicker than normal. That's why it's
water's a problem, and obviously paraffin mixed in. Or
cocktail diesel.
Yeah. Worse.
Anything like that, You want clean, good diesel that you buy from a reputable fuel company.
Sure.
You know, we had that discussion in our previous thing, that you stay away from all these things. So you ask what we're going to find worn inside here. Let's have a quick look. Obviously, to strip down this pump completely, it's going to take us like maybe an hour or 2, and we need some special equipment for that. But I
think just to get an idea of what we're going to see
just
inside.
to get a quick idea, I'm actually not using the correct bracket, but just for this exercise, we're going to have a look inside here, and I've already, just before you guys came in, just
loosened everything.
Loosen the bolts, so we're not going to try and suckle here. Just watch out, Paul, because this head is spring loaded.
And of course, more parts in this pump than you ever realize.
Yeah. Get the turbo out later, but so we just put that there. And then we're going to give it a twist. And
you can hear there's a seal.
As I said, there it goes.
Okay.
And be careful, because if it comes up like this, we're going to see, there we go. So there's the bottom section of the hydraulic head assembly. Here's the shims. We don't want to mix up these shims. We need to keep them together, because this is a setting. Those shims and that springs and the
So this is all preset in the factory.
Yeah, that's when we assemble the pump.
Or you reset it again.
There's a dimension that we do,
okay,
and the check that we do. So here's the plunger of the hydraulic head assembly. This part goes up and down and turns as it pumps. That creates the high pressure that goes to the hydraulic head, or part of the hydraulic head that goes to the injectors that will, pump the fuel through. This is what we call an underspring plate. And if you look at that underspring plate, that deposits that you see there, that's fuel contamination.
So it's got a color of rust on it.
Yeah.
So basically,
we call it browny, rusty deposit.
Yeah, contamination of water in the fuel.
Here we have a plunger washer and a thrust washer. That thrust washer sits to the bottom of the spring plate like this. And as I said, this pump is the lubrication of the pump is from the diesel that comes from the tank directly.
Yeah.
So whatever you have in the tank goes straight into this pump.
Yeah.
And if you break down the lubrication that's in the diesel, you get metal to metal running on each other inside the pump. That will cause failure quick. So once again, tank maintenance, filter maintenance, and make sure you have always
and secondary filters, good diesel,
good clean
absolutely.
fuel supply. So this is my, you can see, as I said, that, and then just quickly here, we need to have a look at the, there's a little shim button there, as we call it, the button, and then here we have the cam plate. Okay, that one belongs there with that one there. As I said, we don't mix up the shims and the springs, they belong as a family.
Sure.
There we have the cam plate. The cam plate is the part that turns, it goes up and down, it pushes that plunger up and down, and this thing distributes, or then it distributes the fuel. But looking at that there you can also see the browny, rusty deposits on the internal part of the pump. Luckily, the cam plate haven't pitted or picked up.
So that's what you'd find. That would be extreme wear, water through the system.
It'll cause the vehicle to totally stop and not go.
Yeah.
It will completely stop. It would not start. You'll have those white smoke bulging out the exhaust pipe. And I mean, imagine being in the middle of Africa and you're having a cam plate like this picked up. And even worse, if the rollers, I'm going to show here guys, I don't want to turn it around now because there's a lot of other stuff that's going to fall out. As I said, there's a stripping procedure, but just for our purpose now, look at the rollers. The rollers are still nice and clean.
So that's showing the life of the pump's been pretty good in the fact that it's had good fuel flow.
Yeah.
Probably hasn't been maintained, and then you're going to find a lot of seals and that.
Yeah.
And obviously there's a rust. You can see this coloration here as well.
And in the inside of the housing, you'll also find that. So
Okay.
if we go deeper, we'll go towards the supply pump and stuff like that. But once we got it stripped and show us, we can take some pictures and show.
The takeaway for me here is really about maintaining this, because this is an expensive component to repair.
And important.
You know, and the regular maintenance, not only of the pump and the injectors, but actually of your fuel tank and extra fuel filters fitted is critical.
Now, worst case scenario, if you got very bad diesel, that rollers and this cam plate, as you can see, they run like this. The cam plate and they run directly on the rollers. The only thing that keeps that metal from this metal is a thin layer of lubrication that you get in your diesel. The lubricity factor, as we call it. If that goes away with anything you add to the diesel, like as you mentioned, paraffin or something like that, or water, then you get metal to metal. The moment you get metal to metal here, this cam plate starts to pick up. You get metal flakes inside this pump. It goes everywhere. It goes and sits there. It even goes through to your injectors. It blocks the injectors. The timing piston gets damaged. The supply pump firstly gets damaged. And it rotates that metal flakes even straight through to the return line. You'll pick it up in the tank as well.
Wow.
So that's why...
And how quickly would that happen? In a sense, I mean, if you're talking how far would you drive?
You need it for 300 kilometers. It'll be more than enough.
You've destroyed it.
Yeah, and then the worst part is, if we're gonna overhaul this pump now, and we're gonna replace all the necessary service parts. The service parts will be gasket seals, those 4 rollers, pins, and bushes. This cam plate is still fine. It can do another round. It's all good. There's no pit marks here. I would pass this thing because it's an expensive component. The expensive components here is the housing, the cam plate, the hydraulic head assembly, and obvious that spill valve there that we see, which is an electronic valve. We test that, and if it's okay, we can reuse it, but if need be, we'll also replace that. But if you get that serious failure, your components that you normally can save, you lose them as well.
So you
lose the housing, you lose the drive shaft, you lose it, then it's become a very, very, very costly exercise.
So the other critical component that we're going to look at is the turbo. And Dirk owns a company called Turbo Exchange here in Cape Town. And that's exactly what they do. You can take a turbo, a factory fitted turbo, into them and they will be able to exchange it. They've got a massive stock of turbos that have been reconditioned. And they've got the top end equipment to check the turbos, to balance them, and to make sure that they're flow tested. So you've got peace of mind that the turbo is going to perform to its optimum when you put it back.
turbocharger, it's made by Toyota. It's Toyota Turbo. It's a CT12B, which tells me it comes from a KZTE type of engine. It's a water-cooled bearing housing turbocharger. Here we have the actuator that determines the speed of the turbo. We'll come there a bit later. We've got the compressor wheel, compressor cover, bearing housing, and then the turbine housing. This is the part that bolts onto the manifold, and the exhaust gas goes through here, drives the turbine wheel, which drives the shaft. The air goes in here, the clean air from your air cleaner, and it's getting compressed into this compressor cover and goes to the engine's intake. Looking at this, we can see that there's oil deposits onto the compressor wheel, which shows us that the engine had excessive some compression or breathing, because the breather tees into the suction line of the turbo. So feeling at the shaft, we can feel that there is play. There should be a bit of play, but the play is excessive. That means that the bearings inside the turbo is worn. There's also some gas seals that we're going to check later. And looking at the blade tips, there was at some stage some sand and dust that went through here, being a clogged air cleaner or a incorrect air cleaner or a pipe that was loose. So the turbo blades will, or the compressor wheel blades will tell us a story that you've got some fine sand marks. If you run it without an air cleaner or dirty air cleaner, that wheel that's this big will become this small. It totally erodes away. It's like sand blasting. And that goes through there, and it goes to your engine. So if you find that wheel is nice and round and buggered, you'll be guaranteed of your rings and your pistons engine. And your sleeves that's all glazed and whatever.
So the critical element, again, it's about maintenance. It's about keeping an air filter clean. And while you're traveling, to clean it regularly to make sure it's sealed properly, so that you eliminate the potential for this.
Sure.
Okay. And then
the important part is the turbine housing. This thing sits in the heat all the time. There's a flame running through here almost the whole time. And there you get what you find. Oh, goodness, look at this.
No, that's part of it. What do you mean?
Oh, my.
No, hell no. This is looking good.
Look at
I thought this was fine.
Look at that nice crack. We'll see it just now once we got it all off. The turbine housing is completely cracked on the wastegate area. Oh, this is a good one. We can try and weld it for you.
Yeah, thank you, but no thank you.
Okay.
So something like that happening, that crack there, I mean, to pick that up while you're driving, probably wouldn't have felt. But I know I'll feel a big difference when it's properly fixed up and it's a new housing, because we're going to have to change the housing.
You know what happens here, Paul? As it heats up, that crack goes bigger. And as the crack goes bigger, the air actually escapes through that wastegate. That's what the name says. It's the wastegate. It's made to work like this. Once your turbocharger reaches, say, 0.8 bar or 0.9 bar, this actuator opens up the wastegate, which bypasses the gas from the wheel straight to the exhaust, which now in that determines the rotor speed of the turbo, which then will determine the boost pressure. So what's happening there, as it's heating up, the crack only goes bigger and bigger, so you get more bypass. So the turbo is not working efficient or at optimum pressure. So that will cause, if you take away the boost pressure, and you have the same amount of fuel that the pump puts in there, it's exactly the opposite from overfueling. It's under-airing.
Right.
So now the guys say you put in more fuel, now starts to smoke, it's overfueling, it's going to burn the pistons. Now what's going to happen here, or it can happen here, is that you're just taking away the air.
Sure.
The fuel stays the same. So you've got under-airing, which is, as I said, the opposite of overfueling, and you will also have exhaust gas temperatures getting higher, which is not good for.
And that's what you're trying to keep a hold on and a grip on, is to understand the exhaust gas temperatures don't go too high, because that's when the damage happens.
And those cracked parts that you see there, they normally goes over the wheel on the other end as well. So you'll have a worn turbine wheel on the inside of there as well.
Well, it's going to be interesting to see once we strip it all.
Yes.
It's obviously very sad news when someone comes and says, you've got to now replace the whole housing. But again, if we'd done maintenance on this, that would have probably been something that may have been.
And remember, it's a component made to wear out and to break. It's like an exhaust manifold as well. The heat erosion. They don't last forever. And then with repairing of the turbocharger these days, especially with this high mileage engine and a turbocharger that's so small that work at high speeds, it's important that we're going to put in a new complete center housing rotating assembly, or core assembly, as you will hear the workshop language now. They fitted a new core, but the correct name for this thing, as we call it, is a CHRA. It's a center housing rotating assembly.
And that's basically
consists of the wheel and shaft, compressor wheel, the bearings, the bearing housing, and all the internal components of the
moving parts basically inside. Okay.
We'll fit a new one, which is a balanced core assembly, and we'll get a new turbine housing.
Yeah.
And we're going to check the actuator. Obviously, there's a diaphragm inside there that can get damaged. There's a spring, and that is also a preset setting on that actuator that we'll check with our actuator test stand with, and to see the correct movements.
So it's not just a simple case of taking the turbo, stripping it down, buying the components, bolting it all back together to get a really successful rebuild of a turbo. You do a lot more to your turbos, because you've got equipment that I think share a bit more about what this does. Your flow bench and your balancing.
Yeah. Most of the guys, when you get all these Google mechanics and stuff like that, and they'll tell you, no, just fit the kit.
Yeah.
A kit is just 2 little bearings, a few seals, and heat shield, and a thrust bearing. Now, how can you fit a kit to components that's completely worn? You got worn shaft, bearing journals, shaft, the ring groove at the back, bearing housing that's worn out, all sorts of stuff like that. When we do the rebuilds of the turbos, obviously on the smaller turbos, I said the best thing is we fit in complete new center housing rotating assembly. But on the bigger turbos, we do marine turbos, we do construction vehicle turbos, we do heavy duty commercial vehicle turbochargers. On those bigger turbos, it's not a matter of just fitting that, but there's balancing that goes towards it.
And you'd balance that center section is what you're talking about. You take that whole center section, built it up on the bigger turbo, and it balances it.
First stage is a rotor balance, where you balance the shaft and the wheel. The slow speed balance, rotor balancer. Then we assemble the complete center section. Then we do a high speed balance on a VSR machine, which they call a vibration sorting rig, which we take it up to 150,000 RPM, and we check for vibration, and we didn't just balance it by grinding the tip off on some sections to balance out the weight. And after that, if you get to the later type turbochargers with the electronic actuators and variable vane geometry and stuff like that.
And that'll be in some of the newer Land Cruisers that we've got already.
Your D4D Land Cruiser. You mentioned the Land Cruiser, but Toyota Hilux D4D and GD6, the 2.4, 2.8 GD6, and then the older 2.5 and 3 liter 1 kd, 2 kd, especially on the 1 kd turbo. It's also made by Toyota. It's got an electronic actuator, it's got a variable vane ring inside there. And for that, to set it up completely, you need a flow bench, which you actually simulate on engine condition, and it checks the actuator, presets the actuator to the correct value. We run the turbo up. I'll show you a bit later there. When we get to that stage, we'll do a quick
So you're basically putting it on the flow bench and simulating what it would do on the engine.
Yes.
With the air coming through and everything you need. Oh,
we run it up to 100,000 RPM quickly. We check the machine measures the air that goes in, and he measures the air that goes out, and we check the rotations of the RPM of the core. And from there we set it up to get it into specification, because you can't put it on the vehicle and it's not, the ECU gives it some instructions and the turbo does not perform as it should, then you also get poor performance.
And I think this is key when you're rebuilding an engine. It's not just about putting the new pistons and cylinder head and all that. It's components like this that often shorten the life of an engine because they weren't repaired and serviced properly. So I think having an understanding of all these different components, it all has to be looked at as a complete picture. And what we're doing here is we're trying to understand that picture, the story that the vehicle's telling us. The sand that got through, the dirty fuel.
But luckily these are nice core to rebuild. It's a good engine to rebuild. Those type of vehicles like this KZ, it's a nice and tough vehicle. Once they're strong, buying an older vehicle, fixing it up properly and doing an overland trip is definitely what I will do personally. I will stay away from the super electronic new type of vehicles. These older,
I think that's something that's key, because the older style pumps and the injectors, and of course you've got the turbo systems, it goes back to simplicity. And that simplicity is key when you've got someone remote somewhere that has to help you look at it or diagnose a problem. So Fantastic. Okay, well, we're going to strip this down and we'll see what we find. Well, we've got it all stripped down, and it's really a lot more parts and quite interesting to see. So, Dirk, maybe take us through what we're looking at here, and then what you see are problems.
Okay, Paul, here we have the CT12B turbocharger from the KZT Toyota. As we said, this compressor cover, which houses the compressor wheel, goes in there. We've got the actuator that opens and closes. It actually moves, open and closes, or forwards and backwards as the pressure goes. Here we have the insert. We got a guide there. We got a shaft, bearings, bearing housing, and here we have the turbine housing that we saw from the outside. Now here you can see that crack actually.
Wow. Okay, all the way through, hey?
Yeah.
And here's your wastegate.
Yeah, your flap valve, as they call it.
Through there.
Wastegate assembly. So this is a total throwaway. Yeah. We're not going to reuse it, so we're going to scrap this. And there's a shaft. As I said, those cracked parts there could have gone through over these blades. You can see the wear on the actual turbine wheel. We call it a wheel and shaft assembly.
Okay.
The wheel is made from a very special material. I think they call it Inconel.
Right. It's for the heat and strength.
It can take a very high heat load. Yeah. This is not your normal cast iron. Sure. And the shaft is then also the part that connects the compressor wheel to the other end. So you'll have this, looks like that. So the exhaust gas drives this shaft, and which then drives this compressor wheel that sucks through there and blows to the other side.
Or so to very simple but quite complicated.
We call the rotor assembly. That's that, and the bearings. Obviously, got the two bearings here. And if we look at the bearings...
So is this like a bronze bearing, or what is it? What's it
Yeah,
it's
like? A type of material that they use. I think it's brass or something that they use for the bearing there.
Okay.
So the bearing goes over here. This is the bearing, and then it houses inside this section here, which is called the bearing housing.
Okay.
So these bearings, there's the bearing housing journals inside there. There's one there, there's one there. It's get fed from the engine oil that goes through there and directly onto these two bearings. If you think of a bearing, you think of maybe a roller bearing that's
like on your wheel bearings.
Yeah, a wheel bearing. Yeah. In this case, it's a bush.
Yeah.
The only thing that keeps this bearing and shaft from each other is the oil pressure.
Wow. Okay.
So that's why it's important to have good oil pressure and clean oil.
Yeah.
There's three things mostly that break a turbocharger: contaminated engine oil, foreign matter coming either from the engine or from the intake.
Right.
Or no oil.
Yeah.
So yeah, oil pressure.
Yeah, and then you hear people talking about you come off a big highway, your turbo's working really hard, just not to suddenly turn the car off.
No, let it idle a bit, let the oil go through, let it cool down a bit. Yeah. Obviously, the oil lubricates it and cools it down, and we also have from the cooling system water running through the turbo. It's a water-cooled bearing housing, so we have water going in there and out. So again, you need to make sure that you got good antifreeze and corrosion protection in your coolant system, because that same water goes through the turbocharger here. You don't want that bearing housing, which is made from cast iron, to corrode through and you get coolant and the oil mixing with each other going and causing engine problems. So also something to look at, cooling system.
Well, totally. I think, it's another key element. When you rebuild an engine, you work through all that process, but you see how critical it is to sustaining the life of the turbo is not just the cooling system, but, as you say, clean oil, changing oil often and frequently.
And here we got the little, as we say, gas rings. There's a gas ring on there. You can see I'll turn it up there. And it goes into a ring groove. Now that part there keeps the oil from the bearing housing not to go through to the exhaust. It's like a piston ring. And it sits in there, which we call the bearing housing's ring groove. Now, that engine that you guys stripped was worn and old. Yeah. Here you can see actually the oil deposits that was burning in or with the exhaust gas. This wheel sits like this, and that's the point there. So all that, what would we call it? Carbon oil composition sits there. It goes onto that ring groove, and it actually wears out the ring groove and the bearing housing at the back. Right. So then you get what they say, no, the turbo seals broke. Just fit new seals. Just put a kit You see that there's no thing as just fitting a kit.
Yeah.
A kit consists of these 2 bearings, a few of these gas rings, and 1 or 2 of these little parts here. There's also an interesting component, it's called a thrust bearing. Okay. It sits there, it sits at the back of the turbo, and it keeps this whole shaft and rotating assembly in place.
Right.
So also the engine oil goes onto there.
And there's grooves there to actually lubricate it.
As you say, it's a thrust bearing. Yeah. So oil goes through there, lubricates it here, and it keeps this rotating assembly nice in place. Yeah. So the moment you get contaminated engine oil, the thrust bearing wears out quickly, and your whole assembly starts to move forward and backward. So if you got it, well, as we say, end float, if you take it on the point and you push it in, you push it out, the moment you get it to do this, it's gone.
And that's because the thrust bearing's worn.
And for this turbo to fail, you need to run it for 5 minutes with dirty oil or no oil, and you'll have a positive for sure failure and a complete failure. Obviously, a turbo, it either works or it doesn't work.
Yeah.
There's no such thing, it works now, it doesn't work later or something. If it goes, it goes. It can last forever or it can break quickly. Also important, we see it a lot at Turbo Exchange. Then the guys come in or they phone, they want a turbocharger. We say we have a turbocharger. We quote
you
them.
do a whole exchange program, which I think is really good.
Yeah, to minimize downtime and so forth. All our turbochargers is fully remanufactured. It's got a guarantee, 12-month warranty and so forth. But now the guy or the customer phones in, wants a turbocharger. We quote him on the turbocharger. He said, put it on the courier for us, thank you. We put it on the courier, we send it, we wait for the old unit to come back. As we get the old unit back, or maybe a day or what later, we strip it down and we say, oh my goodness, this man had a huge oil pressure problem. By that time, you would have already received a call from him saying, I fitted your turbocharger, I started up the vehicle, I drove it around the block and it failed again, I want my money back.
Right.
You sold me an inferior product or something like that. They said, send it back. So at that, we normally get the guy to come to our workshop, as we are here now. We strip it in front of him and we show him exactly what went wrong and say to him, key, when you do a turbocharger, when you replace a turbocharger, determine the cause of the failure.
Right.
As I said, with the air that sucks in there, or no oil pressure, or dirty oil, or something like that, or an oil feed pipe coming from the engine to the turbocharger. Some of them on the inside, the guys doesn't service regularly, so the oil feed pipe, they get clogged up like cholesterol, and it's insufficient oil supply to the turbocharger. That's all the turbo needs for
longevity. I mean,
5 minutes and it's dead.
But if you've got that clean, it's like, as you say, cholesterol, blood clot. Yeah, it's the same thing that's happening here. Your heartbeat of the car can be taken away like that.
For sure. So you need to find out, why did the turbo fail?
But a lot of the story that we're getting, a lot of the picture comes in the stripping, because we're seeing the components that need to be changed. We're seeing why. We know the engine had high back pressure. We know it was using oil. And you're seeing as well on this.
For instance, if you take an engine that dropped the valve, one of the valves broke off or something, we sometimes strip the turbocharger, we get the piece of broken valve sitting inside the housing in there. We can see it on these wheels. If we look at the turbine wheel from there, and we have marks over there, we can say that there's foreign object damage. As this housing here started to crack, look there.
Yes.
You see the crack?
There's actually
a big crack.
Yeah.
As it heats up, that crack expands, and the metal, that hole there, is not round anymore, it goes oval. And here's a clear sign. If we're going to look, I'll show you. Look at the blades there. Feel there. You can feel the marks there.
Oh gosh, yeah.
That's where the metal touched it.
Wow.
So now you get the turbo that will start screaming and shouting. And the moment that happens, it's out of balance.
Right.
So if it runs out of balance, it starts doing that. Imagine taking a bicycle wheel, big bicycle wheel, and you spin it and you keep it in the two studs. Try and do this with it. It does this with you. That's exactly what happens.
It's like a gyroscopic force.
Exactly what happens with the turbo.
Yeah.
As soon as it runs out of balance, it starts to do this with it, and it will just break. This one lasted actually long. That's a good turbo. These are strong turbochargers. So, if it was something smaller, an IHI or something, it would be whoosh.
Well, I know they're going to put it back, completely rebuild it, refurbish it, and it's going to last another 500,000 kilometers, because this time round it's going to be looked after with a lot more care. Oil change regularly, antifreeze, keep it cool. So yeah, thank you. Looking forward to that. Thanks,
Thank
Dirk.
you.
I hope you're enjoying this in-depth educational process. It is a process. It's about helping you understand what it takes to rebuild these components. Remember, you're not going to have to do everything that we've done to this vehicle. And you would do something like this over time. You might not need to do all of this, but just one specific component. And that's where you find your specialist, work with them, make sure it's done properly, and make sure you build back in that reliability to your vehicle. That's going to serve you down the line on your next expedition. Next up, we're going to take the drivetrain. So we're going to take the front and rear diff, the gearbox, the transfer box, to Cape transmissions. And Alaric's going to give us a master class. Honestly, the in-depth look at a gearbox, on what's gone wrong, what's worn out, what we're going to change, what we're going to upgrade is fascinating. I don't think many of us get to see inside a gearbox or a diff. So remember to like and subscribe so you don't miss out on all this valuable information. And visit our website for more information.